Up to this point, the integration by substitution problems we've looked at have all revolved around the power rule, but we can also use integration by substitution with the exponential and with 1 over u. So if I want to integrate 1 over u du, if my function looks like this after I've performed my substitution, my indefinite integral will be e to the u plus c. And if I substitute and I end up with 1 over u du and want to integrate that, I'll end up with natural log absolute value of u plus c. So really similar, we're just kind of carrying over these ideas into this new process of substitution. So if I look at this first example, I have the integral of 2t e to the t squared power dt. I actually think that exponentials are nicer to work with because there's really no question as to what your u should be. Your u should always be that power. U is always going to be the power of e. So u, in this case, will be t squared. Du then will be 2t dt. And I actually see, hey, there's 2t dt right there. So it looks like a relatively straightforward substitution. I don't need to do any extra algebraic manipulation. So when I want to integrate this function, I will have, let's see, e to the u power times du. Well, this works out awfully nicely. E to the u times du, that's just this guy right here. So when I integrate that, I'll have e to the u plus c. And then I just need to take out my u, replace it with t squared. So this is e to the t squared plus c. Here is my antiderivative. Next, I have the indefinite integral of 1 over 4x plus 7 dx. Here, you should kind of look at this, at least when I look at this and I say, well, there's no basic integration rules that tell me how to deal with this, so let me try integration by substitution. If I look at a problem and I don't immediately recognize that as a power rule or an exponential or 1 over x or something like that, I'm going to jump straight to integration by substitution almost every single time. So I'm going to try integration by substitution here. I will take u. Now there's no parentheses here, but that 4x plus 7 sticks out at me as being the most, quote, complicated part of the problem. So I'm going to take out that 4x plus 7 and I will replace that with u. Du then, du is 4 times dx. So I say, okay, here's my dx, but I don't have that 4. Remember this 4x plus 7, that's my u. So I need to get rid of this 4 here. So here I do have to do a little bit of algebra. I will multiply both sides by 1/4 to get rid of that 4. So these two will cancel. And I'm left with 1/4 du is equal to dx. So at this point, it seems like I can make my substitution. I know I'm going to want to factor out this 1/4 because remember dx, this piece right here, this is really going to be 1/4 du. So I'm going to factor that constant multiple of 1/4 out right away. 1/4 times the indefinite integral of 1 over u. And then in place of du, I will have, in place of dx, I will have du. So this is what my problem looks like after I performed my substitution. I look at this 1 over u du, and I see, hey, that looks like that second integration property. That looks like 1 over x dx. So we integrate it almost the exact same way. We will have 1/4 kind of come down here. And then the integral of 1 over u du, that is natural log absolute value of u plus my constant of integration c. And here is my, I won't say here's my antiderivative because I still have one more step. I have my u still in here. I need to replace that. So let's do that real quick. 1/4 times natural log absolute value of u. U is 4x plus 7 plus c. So here is my antiderivative. There, oof, that was a close one. Let's look at one more example in this video. Here I have the indefinite integral of 2e to the negative 3x dx. So this looks similar to the first example that we looked at. So I think, okay, we said that power of e, that power of the exponential function, that is going to be my u. U is equal to negative 3x. So that means I need to find du. Du will be negative 3 times dx. So remember, okay, here is, let me circle this, here's my u. I'm left over with 2 dx, and look at what I have over here. I have negative 3 dx. There's a few different ways you could think about it. You could multiply both sides. Well, let me say this right away. We're going to have to deal with this negative 3 no matter what. But we can kind of be clever about how we deal with this too. There's a couple different ways you can deal with that. For me personally, when I look at that, I see this 2 as a constant multiple. I don't want to have to worry about that when I algebraically manipulate my du here. So you know what? I'm just going to avoid that question altogether. I'm going to take that 2 and factor that out. Since it's a constant multiple, I'm allowed to do that. So 2 times the indefinite integral e to the negative 3x dx. And now I'm just looking at this inside part of the integral. That's a lot easier for me to manage. So that means, okay, negative 3x, we said that was our u. And that means our du should just look like dx. So that means, hey, I just got to get rid of this negative 3 right here. So I will multiply both sides by negative 1/3. So I have negative 1/3 du equals dx. So when I take out this dx, I'm going to replace it with negative 1/3 du. So let's perform our substitution here. I've got 2, negative 1/3, since that's a constant multiple, I'm going to factor that out right away. So 2 times negative 1/3 times the indefinite integral e to the u du. So okay, this now looks a lot easier for me to manage. I look at that, I see, hey, that looks a lot like e to the x dx, so we're going to integrate it exactly the same way. That will be e to the u plus c. This 2 times negative 1/3, we can just simplify that. Let's say negative 2/3 times e to the u plus c. And then, of course, for our last step, we want to take out that u, replace it with negative 3x. So here I have negative 2/3 times e to the negative 3x plus my constant of integration c. So here is my antiderivative. So this video is really just about extending the integration rules for exponential functions and 1 over x dx to integration by substitution, and saying, hey, remember those integral rules that we talked about in the last section? Yeah, they work with integration by substitution as well. In the last video for this section, we'll look at some examples of integration by substitution that are a little bit trickier. They're not quite as straightforward as the examples we've looked at so far. So be excited about that, guys.